Hi guys, my name is Peter C. Dr. Jr., mathematics instructor at the University of Liberia and your math tutor. Welcome to our mathematics lecture today. And in our today's lesson, we will be discussing differential equations, and particularly we'll be looking at the formation of differential equations, or we call it the elimination of arbitrary constants. So whenever you are given an equation that represents the solution to a particular differential equation, what you need to do is to be able to eliminate the arbitrary constants so that you arrive at the differential equation. So what's going to help you is that you will look in the equation for the number of arbitrary constants. So if you have like one arbitrary constant, it means that you have to differentiate once. So that will actually be a kind of first order differential equation. And if you have like two arbitrary constants, you're going to differentiate twice, so and so forth. So the number of arbitrary constants determines the number of times that you have to differentiate within the problem. So for this problem, it says that we must find the differential equation of the family of curves given this equation. So there is actually a family of curves, and we want to find the differential equation from this family of curves. So what we need to do is that we need to differentiate twice because we have two arbitrary constants a and b. If we have three arbitrary constants, we will differentiate 3 times. If we have 4, we will differentiate 4 times, and so forth. If we have been one arbitrary constant, we will differentiate once. So let's get started. Now, this is the function. So we find the first derivative, y prime. Now, note that given y equals e raised to some ax, y prime now for this exponential function will just be a e raised to ax. That is, whenever you have an exponential function to differentiate, rewrite the exponential function and differentiate the constant, the exponent. So the power is ax, so if we differentiate ax, we'll get a. So even if you had e raised to the power 2x or e raised to the power 2x squared, you will rewrite 2x squared, then you multiply by the derivative of 2x squared, which will be 4x. Then you can multiply 4 by this, which is 4x e raised to the power 2x squared. So likewise for this problem. So now the derivative of e raised to the power 2x will just be 2 e raised to the power 2x. So you're just breaking this coefficient down. So we can say 2a e raised to the power 2x. Now the derivative of this one as well. So we rewrite this e raised to the power 2x, e raised to the power minus x. Then we differentiate the power. The derivative of minus x is just minus 1. So minus 1 times this, so it's just minus. So we get the minus from here. Then we move to the second derivative, y prime prime. So again, so it's like 2 times 2 is 4, a e raised to the power 2x, and then negative times negative is positive, b e raised to the power minus x. So we've gotten the 3 differential equation, right? So now we can go ahead to find a differential equation. So this is just the derivative of, the first derivative, the second derivative. This is actually not the differential equation yet. So it's actually just the first derivative of this function and the second derivative of this function. So we now need to formulate that differential equation that ended up with this solution. So what we need to do, we can apply numerous of algebra. So we can use elimination method, we can use a substitution method for the system of linear equation. But for this problem, I want us to use the matrix. So to use the matrix, I'll first rewrite these 3 equations, thereby putting all of these functions on one side and having 0 on the other side of the equation, right? So now, this is y. I send this a e raised to the power x on the left, it will be minus a e raised to the power 2x. I send this one as well, it will be minus b e raised to the power minus x all equals to 0. So I do the same for this. Y prime minus 2a e raised to the power 2x plus b e raised to the power minus x equals to 0. Do the same for the last one. Y prime prime minus 4a e raised to the power 2x minus b e raised to the power minus x all equals to 0. So now I'm going to take the coefficients of all of these, the numerical coefficients of all of these terms, and consider them as the elements of the matrix in this position. And then I'm going to also take y prime, and y prime prime, because within the differential equation we only need y prime, and numerical coefficients. We don't need a, we don't need e raised to the power 2x, we don't need e raised to the power minus x. All of those would have, cancelled if we were to use any other method. So we avoid them and just take the numerical coefficient. So we have y, and then here we have minus 1, here we have minus 1 as well. The next area we have y prime, here we have minus 2, here we have positive 1. And then the last area we have y prime prime, here we have minus 4, and here we have minus 1. So this is the matrix, right? Now, I'm going to use two approaches to solve this, to solve this matrix, thereby finding the determinant of this matrix. So I can use the first method wherein the first row, the first column and the second column, I can rewrite them at the end of the matrix. So I have y prime, and y prime prime. This one, minus 1, minus 2, and minus 4. So now the next thing I'm going to do is I'm going to multiply all of these expressions with the arrow downward. Okay, so this is, and all of them will be all positive. Positive will be attached to them. And then I'm going to multiply all of these ones. Let me use black marker. The ones with the arrow upward, they will all be negative. So this guy is skipping. Okay, so like this, they will all be negative. And then this all be negative. So these ones now, I will have y times minus 2 times minus 1 plus minus 1 times 1 times y prime prime plus, do the last one, what is it? The last one right here, minus 1 times y prime times minus 4. So all of these positive. Then minus. So all of these ones will all be minus. So I have y prime prime minus 2 minus 1 plus next one minus 4 times 1 times y, and we have plus minus 1 y prime and minus 1, all equal to 0. So I can do my multiplication. So y times minus 2 times minus 1 is just equal to positive 2y. 1 times 1, y prime prime is just minus y prime prime. And then this one, negative times negative is positive, so this is 4 y prime. So this first area I'm done. Minus. Negative times negative is positive, so 2 times y prime prime is 2 y prime prime. So it's negative, so it's 4 times 1 times y. It's just negative 4y. And this one, negative times negative is positive, so it's just y prime. All equals to 0. So I have 2y minus y prime prime plus 4y prime minus 2y prime prime plus 4y minus y prime equals to 0. So the like terms, this one and this, y prime prime and 2y prime prime, it gives me negative 3y prime prime. So the y prime and this one, so 4 minus y prime is positive 3 y prime, and then this one, 2y plus 4y is 6y equals to 0. So I can factor out, or I can divide every term by minus 3, minus 3, minus 3, minus 3. So what's going to happen is that we're going to have y prime prime. This one will be minus y prime, and then this one will be minus 2y equals to 0. So this is the differential equation. Or if you like, you can put it in another form, which is by saying the 2y divided by the x squared minus dy by dx minus 2y equals to 0. So there's the differential equation. So what I'm going to do is in the next problem, in the next video, I'm going to use another method to solve this problem and arrive at the same answer. So thanks ever so much for watching, and see you in our next video.